All right, guys, so I know that we have already done the one for Monday, but we're going to go ahead and do the one for Tuesday today. I'm going to show you, it's a pretty long video, but I'm going to try to cut it short so that we can do our questions, our worksheet.
This is a volcano. So is this. So is this. Oh, that's good. There you go. Here's the inside of the Earth. That's the core right here. That's solid iron. Then there's an outer core. That's iron and other metal. And then this part's called the mantle. It's gooey, like hot tar. Down here, that's the crust. It's thin and cool. The core, that's around 1,500 degrees Celsius. The mantle, it's around 1,200 degrees Celsius. I mean, that's way over 2,000 degrees. And then the crust, it's cool, hard as a rock. Now, even though the Earth's crust is really thin, we've never been able to drill all the way through it through the molten rock of the Earth's mantle. That's why to scientists like you, volcanoes are so important. They give us sort of a window into what's underneath the Earth's crust. I think this is your place.
Bill, what are you doing here?
Hi, Jenna.
Aren't you supposed to be doing your show?
Yeah, we're right in the middle of it. I'll tell you what, I need a favor. I'd like to boil an egg.
An egg? Okay, come on in. You're doing that egg as the Earth demonstration, aren't you?
Yeah, that's right, because the shell of an egg is a lot like the crust of the Earth.
You know, you're absolutely right, though. And of course, it's the outside of the Earth, the crust, because it's just for the inside, the core, the middle, and all that really hot stuff that's happening in the kilometers under our feet, right?
Yeah, right. See, if the Earth were like an egg, Earth's crust would be about as thick as an egg shell.
Yeah, and the white is like the mantle, and the milk is like the core. But of course, we can eat the egg.
That's right, science is great.
And nobody cooks an egg of science like you do, Science Guy.
Golly, Jenna.
Hey, don't you have a show to get back to?
Yeah.
New ways to roast weenies on the next Bill Nye the Science Guy.
Easy, you're addicted to volcanoes. Well, it builds up the cone, making it thick. This is what happens in real volcanoes. Now, the way we made this lava here in the lab is mixing vinegar and baking soda. They're chemicals that you can get in the grocery store, and they make carbon dioxide gas. It's the same gas you find in soft drinks. Pretty cool. When I say hot, I mean hot. This is a feather. Hot. Goofy kitchen fish fiddle. Hot. A wiener. Now that is one hot dog. Now, the whole Earth is this hot, or hotter, except for a thin, cool layer that we can walk around on. That's the crust. Whoa. Yeah. Do you guys realize what you've just been walking over? The gusts of Mount Hell, the inside of a volcano. 40,000 years of rocks came spewing out and filled up the valley. So what we're going to do today is we're going to start monitoring the biological recovery. The volcano actually created habitat that has allowed a lot of life to come in and come in great numbers. They're flourishing. I call this the reassembly of life, because one piece by one piece, all the players are coming back in. It's really getting interesting out in the volcanic landscape because there's so much going on.
Ricky, eat your crust. Sam, it forces water out of the tube. The water doesn't come out all at once like a hose. Instead, it pulses. It only squirts once in a while. The same is true in the Earth, like old faithful. The pressure builds up and forces water out of the ground. Not that bad. Science. Science. Science.
Hello. Today on Consider the Following, I'd like you to consider the following. You and I are sitting on the Earth's crust, and it seems pretty solid, doesn't it? But now scientists believe that the Earth's crust is actually made of plates. Not cheap plastic picnic plates like this, but tectonic plates. And tectonic is from Latin word for build. So the Earth's crust is built of plates. scientists actually use corn syrup like this to do studies of what's underneath the Earth's crust. Scientists first caught on to the idea of tectonic plates when they realized how well South America seems to be next to Africa. Not that bad. So take a look here. Here we have the camp stove of science. And in it we have models of tectonic plates. See, right now they're all together. And scientists believe that at one time, all the plates of the Earth's crust were one piece called Pangea. And Pangea, well, that means whole Earth. See, not that bad. Let's say this is the Earth's crust. See, where the plates, the tectonic plates, are spreading apart, that's where we get volcanoes. And where the plates are coming together, that's where we get mountains. Now, you know, the plates are still moving even today. In fact, North America is moving away from Europe about this much every year, about 2 centimeters, about an inch every year. Well, thanks for joining us on Consider the Following.
Okay, it's real important to have shades on in here, glasses, because sometimes things will pop in here. This is molten glass. Watch what happens. Today we're going to make a volcano made out of molten glass. And you will see that the molten glass is exactly the same as the lava. It's a molten fluid. Very, very hot. When it cools down, it'll be hard as a rock. It's the same as volcanic glass. Oh! I reckon that's just about the right temperature for marshmallows.
Now, the Earth's crust is pretty thin, but compared to you and me, it's pretty thick. And some parts of it can get hollow. Look at this. We're in a cave in a mountain in Montana. This cave started out about 300 million years ago when an ancient sea laid down a layer of limestones like chalk. Then just the other day, about 3.5 million years ago, a river was running through here and it hollowed it out. Now check this out. The Earth's crust has cooled so much and become so rigid that it can support the ceiling of a huge room like this in this cave. Isn't this wild? So, stalactite, stalagmite, tight, mite. So, Cass, what do you do?
I like the sapphires in the Earth's crust.
Right around here?
Right around here.
How do we go about getting them out?
We dig for them. Usually we need a shovel, a pick, and a scrape. And usually the biggest person digs.
That would be me.
That would be you.
Whew, this ain't easy. This is some tough crust. Mighty tough crust.
That was the easy part. Now it's time for the hard part.
The hard part.
The hard part.
This is the hard part.
Keep shaking, science guys. Sapphires will fall to the bottom. Let's see where you go. Sapphires would be in the dark area.
This is a sapphire before it's cut.
This is the sapphire after. Cool.
Very cool. Shifting tectonic plates cause earthquakes. The plates are always moving. If you were standing here, you'd be saying, "Whoa!"
This is a device that monitors the movement of the earthquake. It's a seismograph, and it detects earthquakes. Some earthquakes are small, some are very big, and some are huge. Whoa!
Here's a cool trick you can do to show you how scientists know that the Earth's core is solid. See, let's say this is the Earth. Now, when an earthquake happens somewhere over here, people feel it on the other side of the Earth, way over here. Now, let's say we could cut the Earth in half. We get what? Right, a circle. Maybe a circle like this one. Roger, you ready to help with the demonstration?
Roger.
Let's say this can is the Earth's core, and this flashlight is like an earthquake happening somewhere in the world. Let's say, right here. Roger?
It's like people on the other side of the world feeling earthquakes. As you can see, I can't see the light. As I come over here, I can't.
So he makes a mark.
And I come over here, and I can still see it.
So he makes another mark. Now let's say there's an earthquake happening somewhere else. Let's say, over here.
I still can't see it in the middle. And I come over here, I can see it.
So Roger makes a mark.
And I can come back over here and see it again.
And he makes another mark. Now we're going to do what scientists like to call connect the dots. Here you go, Roger. Let's start with our second earthquake here. This would be line number 1, number 2, number 3, and line number 4. scientists figure if the Earth were liquid all the way through, when an earthquake happens on this side, people would feel it all along on this side. But that's not what happens. Something blocks the earthquake waves. That's why scientists figure the Earth has a solid core. And from here to here, it's 2,800 kilometers.
That's filthy.
All right, now that we've reviewed the Earth's crust, we are going to read a little short paragraph and then answer some questions. The Earth's crust can be cracked like an egg. When that happens, we have an earthquake. The Earth shakes and squeezes or pulls the rocks. Mountains are formed when rocks are squeezed together, and large cracks form in the ground when the rocks are pulled apart. Now, let's see how an egg and the Earth are similar and different. You will need a hard-boiled egg, a knife, and a black marker. So if you can get a hard-boiled egg, a knife, and a black marker. Okay, so now once you have boiled the egg, this is just an experiment that you can try after your worksheet. You can do that after you're done with all your work today. Maybe that's a fun activity you can look forward to. So you boil the egg, then you cut it. And then with a black marker, you're able to see the crust just like in the video. And you'll be able to see how similar it is, if not how it looks, how the Earth looks. Get an idea of how the Earth looks from the inside. So here are a few questions to discuss with your group or at home. Number 1, how is an eggshell like the crust of the Earth? So how is an eggshell like the crust of the Earth? So how are they similar? How is an eggshell like the crust of the Earth? Number 2, can you crack an egg? Can the Earth crack? Let's think about that. Number 3, how many layers do the Earth and an egg have? Is it the same or is it different? So answer these 3 questions to the best of your ability, with the help of mom or with anybody that's supporting you through this assignment. Number 4, what are the shapes of an egg and the Earth? Now slice your egg in half lengthwise. Make a small black circle in the center of the egg. Then make a black outline along the outer edge of the egg, white just inside the shell. Your egg should look like this. So this is what it looked like once you boiled it. So this is your experiment, guys. So once you boil the egg, you're going to slice your egg in half lengthwise. Then you're going to make a small black circle in the center of the egg with your black marker. Then make a black outline along the outer edge of the egg white, just inside the shell. Your egg should look like this. So this is an experiment, the one that I was talking about that you could do after the assignment. So after you answer these 3 questions, then you can go ahead and try this experiment. The black dot in the center represents the Earth's inner core. The yellow yolk of the egg is the same as the outer core of the Earth. The egg white is the lower mantle inside the Earth, and the black line is the outer mantle. The eggshell is the same as the Earth's crust. Great job! So you just did an experiment basically on the Earth's inner and outer core. So by using a boiled egg. So now once you are done, I just submit the questions, the 3 questions. The experiment, if you'd like, you can share a video with us, and that would be awesome. All right, well, good luck, and if you have any questions, feel free to contact the teacher.